So I'm Luciano, as also introduced, I work at EPFL Lausanne in Switzerland. I work in different labs. My background is chemistry and biotechnology, working with molecules. For example, you may have heard about AlphaFold. For sure, you heard about that. My group was the group evaluating AlphaFold blindly when it came out. So this is to give you an idea of the kind of things we do. We work with molecules of biological relevance, but in computers, okay? And a lot of it, most of it, I'd say, of this work has to do, of the overall work we do in the lab, has to do with visualizing molecules. So although I had know nothing about geospatial visualization and such, we do use molecular graphics a lot for chemistry. Let me hide the Zoom panel, which is a bit annoying for me. Maybe you don't see it, but I have it here. Okay. So one line of research that I drive at our lab, which is the Laboratory for Biomolecular Modeling, led by Professor Dalperaro here at EPFL. So has to do with creating new tools to assist how we work and how we teach and learn about molecules in general, in chemistry, or what we call structural biology, which is biology but understood at the atomic level, okay? So normally when we want to look at molecules in a computer, we use a flat screen and a mouse, so everything two-dimensional, but molecules are intrinsically three-dimensional, okay? And that's where the problem, the cognition problem arises, especially if you want to handle molecules in space, etc. All that has been like this maybe for like 30, 40 years since molecular graphics exist, but modern technologies using virtual reality, augmented reality, hand tracking, etc., allow us today to handle molecules in space and seeing them in 3D, okay? So our work is, as I just said, about creating new tools that make it easy to interact with the computer in order to see molecules and work with them. And a special twist we have about this is that everything we write, all the code we write, is web-based, okay? And I will explain why this soon. So all the work I present here is mainly done by Fabio Cortés Rodriguez, who is a WebXR engineer working in our lab, okay? So we work together. I tell him the kind of things we want to try to do, etc. He implements this. He's doing a lot of virtual reality research. I do more the artificial intelligence part and the molecular understanding part. And we have already been working together for like 4 years, and we have built some tools that I will present here. So first, one introductory slide. There are things here that are just a lot of hype, and we can discuss about these things later. But okay, so within this set of technologies related to the metaverse, I was saying there are many things that are a lot of hype, etc., whatever, we can discuss this, but there's one thing that is for sure, two things for sure. One is that artificial intelligence is implying a revolution in how we do chemistry and biology, and that's part of the focus of our lab. And the other thing, which I want to discuss here, is how augmented reality and virtual reality allow for much more immersive visualization of data, structures, allow better manipulation of molecules, collaboration at a distance, and hopefully in the future, this will entail a much better way to work and to collaborate, okay? So next slide. As I told you, we make all our programs and tools for the web. Why? We don't like writing programs that then you have to recompile for different platforms, or that you have to distribute in special ways, etc. When you make content that is implemented as a web page, this means it will run on any device. In principle, at least, it should run on any device, in any web browser, and the user doesn't need to download anything to stay up to date with the setups, etc. The deployment is straightforward. You just put the content in a web page, people will access and will use it. There's high standardization, like, different kinds of libraries that run cross-device, cross-browser, etc. And it's quite easy to code an interface. Actually, many of the things you will see here, they were professionally done by Fabio, but initially they were my work, which, not being a programmer, I could still work on. So here you have 3 examples: a smartphone, a computer, and a tablet. On all of them, in principle, we can make these web apps work, okay? So I will show you very briefly the three main developments we have worked on at the lab. On the bottom left, you have molecular web. Then up there, you have molecular web XR and HandMol, which is a new tool we are preparing. So molecular web has been running since 2020. This is a website that we created to assist chemistry education using fiducial markers. Okay, it's a technology that has been around for maybe 2-3 decades, but now the power of the browsers is such that you can run these things directly on the browser on any device you have. And I like to do these presentations interactive, so I will switch to the website to actually show you how it's working, not just show you a slide. So I will switch to my website here. It's called Molecular Web, not XR. I'm talking about, for the moment, about molecularweb.epfl.ch. Okay, you see my screen, right? So this website offers several activities where you use a fiducial marker like this to manipulate molecules. I don't have time to show you much, so I will only take one example here, the virtual modeling kit 2. Probably you're familiar, at least you have seen these programs. I had to switch off my camera. Probably you have seen this plastic toolkits that you can use to manipulate molecules in space, physical molecules. Okay, here the idea is to provide the same functionality, but in virtual reality. So I will open here some example molecule, like maybe, let me look for an interesting one. This one, butanol. Here you can build whatever molecule you have. We have a list to do quick presentations like this. Then when you say start AR, you have the molecule here, and you can control it very naturally, going far or close. You can rotate it in space, okay? The lighting is not the best, maybe here, yes. And we can also simulate the physics of molecules. For example, I can increase temperature and see how the molecule moves. If I have two molecules, I can make them interact. I can change how I see them, for example, like to represent the volume they take. I can do many other things. I don't want to show you this now because it's not maybe the main purpose of the presentation, but the tool is there and it's very powerful. You can have really multiple molecules and see how they interact, handle them naturally. With two cubes, you can make them interact, etc. So I will stop this here and I will go back to my presentation. So we also have content in the website that uses WebXR directly to profit from the kind of devices that we have. For example, our smartphones, they can track flat surfaces, and then we can superimpose objects like this virus that you see there. This is locked on a table. In this case, we don't need any fiducial marker. It just stays there, and then you can walk around it, go inside it, and see it in different ways. Yeah, well, we have quite a lot of material, which is mainly interesting for teachers and also for students who may want to investigate things by themselves. We have a paper in the Journal of Chemical Education, probably the most important journal on chemical education, about the use of molecular web, and then we have some other papers showing some improvements and additions. Here there are some more things. Maybe I can show you this example, not running live to not have to change. But what we have here, this is a piece of ice, okay? So you can see the structure of ice, this hexagonal shape, and then we can simulate through temperature how this melts. But because this is in kind of space without gravity, it's like a drop floating around. Then we can activate gravity and this will go down, okay? Then you can increase temperature further and you will simulate how the water boils. So this is the kind of things that teachers can do. There are many more things, since these are kind of simulations. So in principle, you can simulate what you want. They are not very physically accurate, but they are accurate enough to transmit a visual cue of the process or the mechanism that the teacher is teaching. So the website has been around like for over 3 years, and it's used a lot all over the world, as you can see in this map. We have it free online. You don't need to register. You just go and use it. Yeah, it's in 8 languages. I show you this cube here, which is made of solid plastic, This was done by a teacher who liked the website, and he started doing this to manipulate molecules. But originally, the main thing is you just print this on a page or on a normal sheet of paper, and then you just fold it in 3D. Why do I say this? Because it means it works at zero cost. You just open the web browser, you print the thing, fold it, and you can already use it. That's why there are so many users all around. One thing we presented in our first study is, of course, an analysis of how well it worked or not. And well, I will not go in details through all the plots here, but the main thing is that a big fraction of the users had no experience, but they could make it work. You see, here we tested this online through surveys that are automatically collected by the website, and also through some teachers. This is what we have here on the right, who were trying this hands-on and connected to us. So one thing that we cannot evaluate, because it's difficult to articulate with the teachers, is what the real pedagogical effect of the website is, okay? What we do know for sure is that it produces a lot of engagement that we measure through teachers. The part we don't know very well is what the actual effect on learning is. This is a kind of study that's super interesting, but unfortunately it's hard to articulate with the teachers to do good tests on students. Maybe someday we will have it, I don't know. What's important at least is that it does promote engagement, so students want to investigate the thing. So the second thing I'm going to show you is Molecular Web XR, which is a website, also a website that is out now since last month. When I presented this slide, I showed you I explained why we like to make all our tools for the web. But it's important that these VR headsets, they have a web browser inside, okay? And there is a standard called WebXR, which is analogous to OpenXR, but for the web, which is very well maintained by different vendors and developers of hardware software, okay? Which means that in principle you can create a single app that will work the same in all these devices, okay? We use in particular the Oculus Quest 2, which is today quite accessible, affordable, at 350 francs at least here. There's a browser inside, it supports WebXR, and it can do things like tracking your environment and tracking hands, okay? So it's quite powerful. At this point, so this thing that is important is a WebXR standard, which allows us to make a single thing that will work everywhere. And what Molecular WebXR allows you is to create a room with content that we predefine to address different topics in chemistry and biology, or also your own room, and then to have multiple people working inside that room. So here, for example, you have this was a special session during a conference in Bern last year. This was a normal format conference happening with people presenting there, but we had some 4 lectures that happened inside VR. So you have, in this case, 5 people. You see them here. Okay, there's a person here in the back. I don't know if you see that. And then each of them can see its own hands and the avatars of the other people. Okay, and on top of that, so in the middle of the scene, we have the virtual objects that the people want to present. And you see, for example, this person, how he is explaining something here. You see the hand, the position is the same in the virtual and the real world, and he's explaining something about the interface between 2 proteins. This is something that you can do in a flat screen, but it's far less clear, especially if you want to explain this to somebody else. Maybe if you are looking at it for yourself and you have been looking at structures for 20 years, it's good enough. But when you want to explain it to somebody, even with experience, it's not the same. In 3D, much more immersive, and using your hands, it becomes very natural. Here we have the same tool, but applied to an open science day at EPFL, where we had, actually it was a weekend, over 2 days, we had over almost 150 people trying this, where a student here, prepared to explain the contents, is navigating the people through different concepts about biology, physics, and chemistry to try to connect this. And all of them are inside VR. What you see in the background is a viewing in real time of what's happening inside the VR session. But this is not the view of any user. This is an independent session open on another device. I can show you this running So a video I have here, for example. I don't know if the video will be transmitted in real time, but yeah, the idea is that with a separate computer, we can monitor what's happening inside. Or if you invite somebody to talk, to follow the discussion, but this person doesn't have a VR headset, it's no problem. They can just go with their computer or smartphone. Of course, they cannot manipulate things, but at least they are there. Okay. And we have had people from aged 12 to 80, and they could all follow the thing very, very well, because the devices have evolved so much that they are very easy to learn to use, and yeah, very, very natural to use. So what kind of things can we do here? What I showed you in this case or the previous case, all the people are together in the same physical space. But of course, when we built this tool, what we wanted was the opposite, is to bring people who are far away together. Okay, this is only one specific application you can have. The real thing is something like this. So here I have a friend in Argentina. I'm from Argentina. He's teaching chemistry using our tool. He's the person in blue here. You see the head on his hands. And what I did was to fall into the session he was doing from Switzerland, 11,000 kilometers away. And through the built-in audio that we have in the website, we can just talk naturally, and I can also interact with the same objects that he is interacting with. So this is just out. As I told you, it runs in all devices. What you have here, for example, is how the tool looks in a smartphone. Okay, you have a person in blue who is using a VR headset. That's why you see his hands and his head. And I'm looking at the session through my phone. What I can do is I can click Enter VR, and the WebXR standard will automatically split the view in two and do stereoscopy. So I can plug my phone inside one of these cardboard goggles that you can get for $5, and then I can follow this immersively using my phone. Okay, I cannot grab things because the telephone doesn't, the smartphone doesn't track hands for the moment. Maybe it will in the future, but at least I can follow the thing immersively in 3D. So that was Molecular WebXR was released just 3 weeks ago, and we are starting to see people using it in different scenarios. We promoted a lot for education and for science communication, but we have seen people who do research who like it, especially to discuss things. Maybe not to really work much for the moment, because each molecule here is a kind of rigid object that you can manipulate as a whole, but you cannot change. Okay, so it's okay for visualization and for discussion. But now for the other thing, for really manipulated molecules, we have a new tool coming up that's called HandMol that I would like to show you quickly if I can. Really hands-on. Do I still have maybe 3 minutes?
Yes, we should wrap it up, but please, yes.
Okay, then I will move now, and it may be that you will lose me for a second. Just tell me if you still see my screen.
Yes, we can see your screen. Microphone is up and down, but we can see your screen.
Sorry about that. Then the problem I had yesterday is still there. High floating mid controls. I will go to my Meta account where I can cast. I will move a bit. You just tell me if do you see me typing now?
Yes.
Okay, so what I have here is this website where I can load a molecule, but not like before where everything was just 3D objects. Now what I can do is really to load a molecule. Like say this, I parse the PDB. The PDB is the file that contains all the atomic coordinates. I do enter VR, and now do you see some molecules in front of me?
Yes, we do.
Okay, and what the kind of things I can do is like with my hands, literally just grab it, and you see I can not only move it, but also deform it, okay? And this is assisted by a force field that simulates the mechanics in real time, okay? It's a very simple one, but now we are working with people who develop real force fields to try to make this even more physically real. Okay, the molecules can interact, and the kind of things I can do with this are, so the opportunities, the possibilities with this are limited only by what you imagine. And I will tell you very briefly about some examples that we have, but yeah, essentially this is the main kind of thing that allows you to do probably more than just look at things, but really deform the molecules, change what is called the conformation, which is the arrangement of atoms in space, etc. So I will go out of VR now to go back to my presentation.
Yes, we need to slowly wrap it up. We are slightly over time, Luciano.
So you don't see me, right?
Your camera is off, yes.
Yeah, because I had to stop it to show you the other thing, because it uses the webcam. So yeah, I was then telling you this new program that we call HandMol, because you manipulate molecules with the hands. Has applications in teaching about conformations of molecules, also in designing new molecules, in docking molecules to proteins, which is the basis for how drugs work. And yeah, it's a very, very new technology, but I think it's very powerful. There are already some companies interested in the kind of things we can do with this. And for the moment, these are prototypes, this last one thing that I showed you. But yeah, I'm very excited to have it running finally. It's something that I wanted to have since I started working with molecules like 20 years ago. So with that, I'm done. I tell you again that all the coding here was done by Fabio Cortés Rodriguez, an amazing person here and programmer, artist, WebXR artist also. You can know more about everything that I show you here by going to this link or some other links that you saw there. And then this presentation, I understand it will be available, so you have these key references there. And yeah, you can always write and follow us on Twitter to know more about what we do. And I have to say thanks to the SNSF, which funded most of this, and also Hasler Stiftung, which gave us the first funds to start working on this. So yeah, with that, thank you.